Assalamu alaikum wa barakatuh. Today we'll be talking about IP communication. Actually, IP communication as a topic is not related directly to KNX. However, IP communication is the core of most of the communication are doing in these days. From your CCTV to intercom to mobile application, all of these are connected via the IP communication. And now IP communication is part of the KNX Advanced Course, and it's a mandatory part now, so it's also covered in the exam. So today we'll be talking about IP communication from different aspects. Having an IP network, an IP communication network, which is efficient and configured in the right way, is the core of any successful smart home project. Many of the projects that we audit or we check or we do some kind of troubleshooting, we found that the issues are related mostly to the IP communication, not to the KNX communication. Today we'll be covering IP communication from three aspects. We'll talk about IP communication from foundation and pure IP network aspect. We'll talk about IP communication with the foundation of what's IP, what is the IP communication, what the OSI layer. So we'll talk about IP communication as a theory part from the foundation. And then we'll be talking about IP communication and its relation with KNX. So we'll be talking about KNX interfaces, KNX IP interfaces, KNX IP routers. In the third part, we'll be linking all together with the practical part. We'll be talking about the tools you need for efficient IP configuration. What are the tools you need to troubleshoot your IP network, Windows tools that you have available in your laptop. And we'll talk also about the configuration, the practical configuration of an IP interface or IP router. My name is Wissam. I am a KNX tutor and KNX and Smart Home Consultant. If you have any question, get back to us. Let's start. Assalamu alaikum wa barakatuh. As mentioned before, today we'll be talking about the KNX Advanced Course with the IP communication part. And we'll be talking about the IP communication part from the KNX point of view and also from the general point of view, which is needed for most of the IP communication nowadays are used in most of our villas and most of our communities, okay? So today we'll be talking about the basic knowledge about the networks in general. IP networks, one of them. Also talking about the IP communication with the KNX, and then the third part will be that practical part, showing some tools that will be used in the IP communication and showing also the IP communication and KNX communication part in a practical way. An introduction here is important because IP communication is very important now for our communication. Most of your communication here is IP communication. If you are watching this video on YouTube, this is an IP communication. If you're watching this video via Zoom or Microsoft Share, we are doing an IP communication now. Most of our video streaming, audio streaming, online activities are all IP communication. Your intercom is mostly using IP communication. Your camera is mostly using IP communication. So IP communication allows wireless connection, wired connections with very fast speed, with bandwidth that can carry videos with very high quality. So IP communication is very important. Our KNX system, we use IP communication to communicate with the KNX server, with the IP interfaces, with ETS if needed. So with devices among each other, because we can use an IP router to carry data from the TP part to the other TP part via IP communication. So IP communication is very important, and having your core IP network configured in the right way is crucial to your KNX projects. So let's go for some very basic concepts. When we talk about transmission in general, we talk about three types of transmission. It's either point-to-point, where one device is talking or sending and receiving data to a different device, so it's one-to-one communication, or broadcast communication, where one device is sending to all the devices, okay, like screaming that I need help, okay, or getting data and they need to check with all devices about this data, or multicasting, which is group of devices. So one device is sending to group of devices. We use this mostly to find the IP routers or IP interfaces in our project. If we talk about the network classes by scale or by size, we can say that very small networks like one PC or something, this is what we call personal area network. If you have a project or some network that covers a room or a building or a campus, okay, this is a LAN, so your office has few laptops connected together via router. This is a local area network, LAN. If I have something a little bit bigger, covering maybe a compound or a city, this can be a metropolitan area network. This is not used a lot. Or we have a WAN. So if your location here in Egypt connected to your location in UAE, like our cases, then this is a WAN connection, which is a wide area network. Or you can have the internet, the biggest global network covering everywhere. Of course, this network can be wired or can be wireless. So if you have a network wired connection, say you have an Ethernet switch connecting the wired devices, this connection is mostly using copper, what we call Cat6 cables or Cat7 cables. It's using mostly a UTP connection, what we call a UTP cable, which is the cable that has 4 pairs, so 8 wires, okay, unshielded twisted pair. Sometimes you have a shielded part called STP, and this is a copper connection. If you are connecting switches to switches, you can also connect using fiber connection, with a fiber optic connection, offering much higher speed. Or you have a wireless connection like your Wi-Fi. This is a Wi-Fi connection, so you have a Wi-Fi access point connected mostly to the wired devices and then sending data wireless to the other devices. If you are using Wi-Fi connection, there is an encryption, of course, and Wi-Fi connection now comes with the older range 2.4 giga using the frequency 2.4 gigahertz, which is covering a good area, but the transmission speed is not that high. Or you are using 5G. This is not the 5G of the mobile network. This is the 5G where the device, the Wi-Fi access point, is using the frequency 5 giga, which covers less area but higher speed. Okay, this is general. You find this more details in most of the light current courses or in the CCNA course. Here we are talking only touching the foundation and the specific parts. Now we're talking about the layered communication. Layered communication is a concept which is used in the network connection and mostly in our life. The idea is that we need to reduce the complexity and make sure that if I have some changes in my network infrastructure, I'm not changing everything. The concept is very simple, that instead of each collocation talking to the other location from anywhere, we're talking about different layers connecting to each other, and one layer is responsible for communicating to the other areas outside the protocol. So I have here one location. So I have location A and location B, an expert in each location talking a different language. So this guy here in location A is talking English, location B is talking French. They need to communicate together. Okay, so the way to make it via the layer communication, that I will get a common translator. Here this guy or this lady in this case talking English and Dutch, and the location B Dutch and French. And to send the data, there is a secretary here that will take the data and send it by fax to the other location. And here the communication between layer 3 is talking only to layer 2 in this layer communication in location A, and 2 located to A1. Only layer 1 in location A is talking to layer 1 in location B. Hence, whenever I'm going to change something, I don't need to change anything in location B. I can change it in location A only. So if I want to change the language, then I can change it location A and location B, but I don't have to change in the different location because only one layer is talking to the other layer. So this is a layered communication in a very simple way. Tomorrow, if I want to change the media from fax to email, I have to change here email and here email, but no other changes will take place in layer 2 or layer 3 in any of the locations. So it's a very simple way, and each layer will be talking to the different layer up or down, sending or receiving data from this layer, and then layers are talking to each other. Here is the OSI model, which is covering the network layers. The OSI model, we have normally 7 layers, from physical layer to application layer. Physical layer is more into hardware, okay, where you have the bits and bytes. Application layer is mostly onto the application itself. I'm not talking about the application you're using on your laptop. I'm talking about the application that will be used as an execution port of the application. So as an example, if you're using a web browser to access the internet, then you are using a web browser. This is your application on your laptop or mobile. But the applications that TCP/IP knows will be called HTTP or HTTPS, which is how data is encoded and how will be translated and transferred on the different layers to reach your destination and get you the data that you need. Here that you can see that in layer 1, I have a lot of data and a lot of headers. If I'm moving from layer 1 to 2 or 2 to 3 or 3 to 4, then a lot of headers are being removed. So in layer 7, I have the data and layer 7 headers, and the difference also in the other way. So in layer 7, you put something like www.google.com, then other layers will be adding different devices, making some encryption, making some translation of the data to be reached to layer 1, where you have the physical media itself. If I'm talking now, I'm putting now this model of this OSI model to that TCP IP model, you can say that only 4 layers are being used in this model, which is the application, the transport, the internet, and the link layer. In the application, you can see that you have a lot of applications like HTTP, like TCP, like DNS, a lot of applications. In the transport, we have 2 protocols, what we call connection-oriented protocol and connectionless oriented protocol, the TCP and UDP. We'll talk about them in details. In the internet, responsible for the addressing mostly, so you have the IPs, you have the communication, you have the routing. This is where the router and switches are playing around. And on the physical layer, in our case it's a link layer, we're talking mostly about the network interface with the physical layer itself. Talking here about the physical layer, we talk about the MAC address in the link layer in our TCP IP. MAC address is a very simple number. It's a unique address, and as usual, an address meaning that will be unique will have a hierarchy, like we say in IP address or individual address. This MAC address is mostly coming with the device itself. So any network card that you have, wireless or wired, will have a MAC address coming from the factory. It has 2 parts. Each part is 3 bytes. So one part is vendor code, one part is serial number. This is 24 bits, so it's around 16 million something for each code in the vendor, and the vendor can have many codes. And this is a unique address, so from each factory, if you are getting a MAC address today and a different device today and a different device tomorrow, each device will have a unique MAC address, which is a physical address. Normally you cannot change with the normal tools. In the internet layer, I have mostly 3 playing protocols. The ICMP, which is normally used for a tool called ping, and it's used to send the messages for the point-to-point protocols. For the IGMP, this is most used for the multicast, where I need to contact different devices together, or the ARP, address resolution protocol. The ARP is very simple. It has to map the MAC address, which is the physical address, to something that we call IP address. If I'm talking about the internet layer, so this is a higher layer where I'm talking about the address. I will have an IP address. IP address is similar to the individual address. IP address for each device connected to the internet or the network, you should have an IP address. IP address is a unique address. It cannot be duplicate. This IP address will reflect the network you have. So in your network, in your house, you have a specific, let's say, number that you are allowed to use, reflecting the local area and the wide area network. There is an IP address version 4, which used to be still used widely. And then there is IP address version 6, which came to life in order to increase the number of IPs available, because it can use 16 byte, not only 4 byte, like IP version 4. And with this IP address, you can reach a lot of IP devices or IP addresses. However, it's not used a lot now and not compatible with a lot of devices yet. IP addresses are divided into 2 categorization. One is public IP address, which should be a unique worldwide address, and mostly this can be assigned by the IANA, like your address you get from Etisalat, your address you get from Vodafone, or an ISP, internet service provider, or a private IP address, which is normally you are using in your house. So in your house, if you are using an IP address like 192.168.1.17, is mostly an IP address, and you find that all your IP addresses are like that, 1.18, 1.20, like that, okay? But you'll find that your router, when it's connected to the Etisalat or to your SP, has one IP address, which is we call public IP address. This representing your router, representing your house. Okay, and this IP addresses has a subnet mask to determine if this IP address will communicate locally or will also communicate globally. We'll have to go to the internet router and reach other areas as well. So depending on your IP address and your subnet mask, you can state how many local IP address I have. So like in our example, I can have in my local area network using this subnet mask maximum 254 addresses. If you talk about the transport layer, here we are talking about the connection and the connectionless protocols. So in our case, we have a TCP connection and a DB connection. A simple example here, if I have my mobile and I call someone, I have to open a connection first, so I have to establish a connection. The other part should answer my call. Then a connection now is open, and once the connection is open, I'll be able to send the message and talk and receive and listen. Then this is a connection related protocol. Once I'm done with transmission, I can end the call, meaning end the connection. This is TCP in a very simple way. So TCP is a protocol, it's a very reliable protocol, not that fast because I have to open a connection between the sender and the receiver. It's a point-to-point protocol connecting point-to-point devices. UDP, on the other hand, is not connection-oriented protocol. It's like SMSs. You just send the message, reached, it's fine. Not reached, you have to resend again. But there is no connection open. You just go there and send the message. Okay? If I'm talking about the application layer, you can have a lot of applications like the DNS, domain name system, which is a resolution from the name, like when you say www.google.com, then it will be translated using the DNS server to an IP address. And then using the ARP, something called the ARP, will translate the IP address to MAC address. Then it will be physical data which is going through the wires or the wireless connection via the internet. Normally you have internal IP addresses and external IP address. The internal IP addresses, let's say here in this area, and here this is the internet. Whenever you are talking to a server on the internet, you are using your local IP address internally, but once you are getting outside, it's the IP address, which is the public IP address from the router. And then once you are reaching the router again, the router is responsible for dispatching those requests coming and giving it to the internal IP address related to the connection itself. So this router here is acting like a gatekeeper or a dispatching area where I'm taking part from this laptop, sending to this server, taking the answer from the server, getting it back to the laptop. Okay, the server itself doesn't know which IP address it should go back to. This is responsibility of the router. And each service here will have what we call a port. A port is something like an extension to the IP address itself. So I'm talking about as an example. So if I'm using HTTP, it uses service or port 80. So all connection will go via port 80. Here talking about the devices, so mostly in the Ethernet connection I have a switch. Switch device is now used to connect devices together. A router is mostly used to connect devices from one network to another network, okay? And then a gateway that can be a firewall or a quality of service device that makes more encryption or more processing to the data itself. Now we talk about the KNX system. And in the KNX system, we'll talk about the application layer, which is using here KNX Net IP, and the UDP is being used, also a TCP somehow, with the network layer IP and the Ethernet as a physical layer, which is connection. KNX system here is very simple. I have a TP telegrams on my TP devices and need to be sent via the internet or via the IP communication. I have to use what I call IP router or even IP interface, which will have a KNX port and an IP port. An IP port should be configured using the IP methodology I'm using. KNX port should be configured using the KNX methodology or address I'm using. So as an example here, in the IP port, I have a MAC address. As mentioned before, it has two parts, part for the vendor, part for the serial number. I have an IP address. IP address should be unique and can be entered manually or by administrator or assigned by the DHCP server. DHCP is a service, can be installed on a server or on the router, responsible for assigning an IP address for each device. So if I have a device today connected to your Wi-Fi network, it will go directly communicate with the DHCP server and get an IP address from this. And the DHCP server then will mark this IP address reserved to Wissam laptop. So it will not be assigned to any other device. Okay. IP6 is not used. Okay. Here is the configuration of a simple IP device in the KNX. So there is an IP address I have to assign manually or via the DHCP. Then I have the multicast address, and this multicast address is responsible for the devices to see each other. So when I want to reach the IP routers are all listening on this multicast address. Okay, so I will go and send to this address, and all the devices listening on these addresses will come back to me. Here we talk about the bits and bytes of the header. We'll not talk about that. IP communication is mostly tunneling or routing, and we'll talk about them together. If I have an IP router, then I can use it as a tunneling interface or a routing to route from line to line. But IP interface will only be used as tunneling. Here is tunneling. Tunneling is a connection-oriented transmission of KNX telegrams in all IP frames. So mostly it's used with ETS, using connection-oriented transmission. So in ETS, when I'm trying to access an IP, a KNX system using IP interface or IP router, I'm building a connection between the interface and my ETS. So it's a connection-oriented connection, and this is what we call is tunneling, okay? And then we have a tunneling request and tunneling acknowledgement that will be sent via ETS in a connection-oriented protocol. Here's an example. I have here an IP router. Here's the internet. Then the data will go from my ETS device to the IP network, to the router or to the router here, IP router here, and then will be distributed based on my destination to the different line couplers and then to the different devices. Okay. Here, if I have more than an IP router, then I can also go from here to the different device. Okay, and we'll do this practically later in the video. Then the tunneling settings, I have to configure the following. I have to put the address. Okay, the inverter address I have should be related to the inverter address of the project I have. IP address should be related to the IP address network or IP network I have. Then the port 36171 is the default one, and then the rest I don't need to configure. This is already the MAC address, which is already configured with the device itself. Okay. If you want to address or to access your device remotely, so you have a KNX system here and an IP router installed, then I need to access it from the internet as an example, like here. Some people are doing what we call port forwarding. Port forwarding meaning what? Allowing the internal router to expose the internal IP KNX interface to the internet directly. So from the internet, I will have direct access to the KNX IP interface using what we call port forwarding. So the router here will allow this. This is not recommended, totally unsecure, totally insecure, because once you access the IP router, you have access to all the device, especially if the IP router is not secure device, not using IP secure or KNX secure. If it's not using KNX secure, then there is no encryption, then you have total access to the network inside, the KNX network. So this is not recommended at all by KNX, but what recommended is using one of two methodologies. Either using a VPN connection, so that the device here, the IP router is connected by VPN connection, virtual private network or encryption takes place and it's a private network, and then your device is also using a VPN server to connect here. So this is the device here connecting via the internet by VPN, and the VPN is also used in here. Or you connect using third-party servers like ABB server, One Home. Many servers are allowing that. In this case, you are not comfort click Iridium. Then in this case, you are not connecting direct to the IP interface or the IP router. You are connected to the server itself, like IP server, and then the server will route your commands to the IP interface via a secure connection. So in this case, you are not connecting direct to the IP interface, but connecting via a specific server. Okay, this is the two recommended ways of connection. Routing is not ETS connection. Routing is mostly allowing telegrams, so normal communication telegrams, to go from one device to another device via IP router, which is used here as an IP coupler connecting lines together. Like this case, as an example, you have here the IP network, maybe this is your switching network, and here I have IP router with line couplers, another IP router, and data will go from this device to this device. So the IP router can reach this device. IP router also have the ability to act as an IP interface, so allow tunneling, and also they will have a filtering table. Okay, so they can filter data, so it can really be used to organize the traffic to make sure that traffic is controlled. They can filter data, they can block data, they can allow data depending, just like you are configuring a line coupler or an area coupler as well. Okay. That was all now for this part of the course. We will be talking about the practical part. My name is Sam, KNX consultant, smart home consultant, KNX certified tutor. We are here in UAE and in Egypt as well. If you have any question, let us know. See you. Assalamu alaikum. Assalamu alaikum wa barakatuh. Today we'll be continuing our part of the IP communication with KNX. Today we'll be talking about the practical part. So we'll be talking about more tools which is available in Microsoft Windows in your laptop that can be used to know more about your configuration, know more about your IP configuration, and even make some diagnostics about your IP settings and IP communication. So we start here now. I have now here my command prompt. The first command, very simple one and very basic one, is ipconfig, which will show you the network card that you have and the basic configuration about each network card. So it shows me here that I have an IP address with this number, and this is my subnet mask, and this is my IP gateway. And as we said before, the IP address is a unique address, this IP version 4 address, which means that it has 4 bytes. Some bytes related to host ID, some bytes related to network ID. Network ID meaning this is related to the external network. Host ID meaning that's related to the internal network. And whenever there is a packet that I need to send it outside of my network ID, it will be forwarded by default to the default gateway with the IP address here 192.168.1.1. If I need to know more info, I can just go and say ipconfig/all. Now I have more information. Now it shows me the following. Now it shows me also the MAC address. And like we said also before, MAC address is a unique address. It's a hardware address related to the network ID. The first 3 octets are related to the vendor. The other 3 octets are related to the serial number. And here you can see that I have different MAC addresses, maybe from the same vendor, but of course different serial number. Also shows me that this address is from a TCP server, meaning the IP address, and this is also my DNS server. And in this IP address, I have something that we call leasing, because the IP server doesn't grant me the IP address for good. Normally there is a lease time. Lease time meaning that this IP address will be assigned to this computer or to this mobile for a specific time. Then if the time passes by and the device is not connected anymore, then this IP address can be assigned to a different device later. This way, the IP server, the DHCP server is trying to make sure that the addresses are assigned in a very efficient way. So as an example, my address is going to expire maybe in few hours, okay, and then it be renewed, or get another address as well. What else I have? I have the DNS server here. DNS, Dynamic Name Resolution Protocol. This is where we are this is the server that has a service that we are using to resolve the name from a name to an IP address. Because go to your web browser and you say google.com. You don't say 174.number.number.number, okay? But this server and this service is responsible to resolve from the name to the IP address itself. So as an example, when I shall come here and say nslookup google.com, it will go to the server and resolve the name from name to address, which is 172.217.18.46. If I make a ping, and ping is a very simple command sending ICMP traffic to another host and getting the feedback. Make sure that the host is responding. So if it is responding, then mostly it's connected, okay, or not. So as an example, if I go and say ping 192.168.1.1, this is my local gateway, and now it's responding, so data has been sent and received, no losses. KNX. Now let's go to the KNX port and talk about it. See, in my hand here, I have a very simple IP interface from ABB. This is an IP interface, so it has here the port where you connect your RJ connection, like this one. So this is RJ connection, Cat6 cable, RJ45, which is using 8 wires like we said before. Once you connect here, you get the Ethernet port connected. You can see even here, this LED start blinking. Okay, this using PoE by the way. And here you have the KNX port and even auxiliary power port if you want. So simply you connect it to the IP port and you connect the other part to the KNX port. So let me connect this to KNX port as well. Now it's connected, so let me go and open ETS. As you can see, ETS is open here. Let me make a new simple project to test the IP configuration, IP test. Okay, default configuration assigned by me. And here I have a building. Let me go now and check. Now you can check the interface itself. As you can see from here, the interface detected, the IP interface is already detected automatically. As we said it before, there is a default port 3671. Once you have an IP interface on it, ETS will detect it automatically. And even you can see the port and the individual IP address, the local IP address is also shown here, as you can see. If you're going to try to check any configuration, you cannot do any configuration from this area. It's mostly only for viewing only, but you can see here that you can see the address and the individual address as well. So now let's now go and try to insert the device itself, add the device in the KNX topology. So I move to the KNX topology, look for the device. As we know from the basic course, here I put the order number. This is the one, okay, add it. Since it's a secure device, then it should have a password, but I will cancel the security, so I will not add it now as a secure device, but a normal device. Now if I go now to the diagnostic port, I should be able to deal with the diagnostic port using the IP interface. As you can see from here, this is the line scan. If I can check, the IP interface is already selected, so I should be able now to scan my devices using the IP interface. See, devices are coming. The line scan is now working using the IP interface, not the USB interface as we used to do. This is even now done without any configuration at all. If I go now to the interface itself and check the configuration, here I will be changing the individual address. Let's make it something that I'm sure that's not in our topology anymore. Here you can see that this is the IP port, where you can make it a DHCP, a dynamic, or a static one. The normal ports are the normal ports, nothing else is here. If you go now to the parameters, you find that the IP interface normally doesn't have parameters. If you have an IP router here, then you will have different parameters related to the filtering, but now you're mostly done with the configuration here. You see, there is nothing else you can do. If you want to download now, you can go download. I will download all. Remember, you download all when you want to change the address as well for new devices. Now I put the device in the programming mode by pressing the programming button. Now device is being downloaded. Of course, if you are not yet familiar with this part, you have to get back and review the basic course, and all the practical of the basic KNX certified course is already available in our YouTube channel as well. Now you can see that address is done. Now the application program is being downloaded. Now almost done. Yes, now it's done. Okay. Now if I go now to check here from here, I can also go for the device scan, put the address, which address we checked. Okay, this is the address that we chose. So I put the individual address here, and I'm still using the IP interface to read the IP configuration. So now I can read the IP configuration of the device itself. From here, you'll be able to see the individual address. You can also see the IP address, and most of the configuration you need to find out will be found here. If this is an IP router, you can also see information about the filtering table if you have a filtering table enabled. Of course, from the basic course, you know that you can even print this interface, this information. And again, these are the new configuration after we implement the device and program the device itself. That's it for this part of the course. My name is Wissam. I am a KNX certified tutor, KNX consultant. And if you have any question, let us know and see you. Salam alaikum.